With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, consider a block of mass m attached to a spring or spring constant k as shown. Now the block of same mass m moving with velocity u strikes other block and stick to it. Both the block collectively perform SHM. You have to check out of ABCD which option is the correct. So we have to find out the amplitude. So if you see here, right now what is the extension in the spring? So extension in the spring should be such that if this m block will be at equilibrium. So let's say this is x1, right? So I will write down the net force on it. It is this. From here I will write down this. Now if you see here, when this block will stick to it, right? Then let's say it extend more and equilibrium position reaches, and extension in the spring is x2. And since the block is stick to it, right, then the mg will be here, the weight force here will be 2 mg, and in the upward direction kx2 will be there. From here if you equate these two, since we are finding out the equilibrium position, so how much displacement occurred here? If you see, earlier the extension in the spring was mg by k, now it is 2 mg by k. So how much it shifted downward? It shifted by delta x, that is x2 minus x1. So it is 2 minus 1 mg by k, that is mg by k only. So this much is the shift of this block from the equilibrium position, right? So it means that it is at a distance of, if I say this is the equilibrium position, it means that it is at a distance of mg by k from the equilibrium position, right? This delta x is from equilibrium position only. Let's say this as x naught, right? And here it is having some velocity, so you can get the velocity, right? If you see, let's say it will strikes and it will have some velocity. Initially the momentum of the system is mu, and after they will stick, they will have a common velocity, right? Let's say they have a common velocity of u naught, and since there is no impulsive force in vertical direction, so I will write down initial momentum and final momentum equal here. So from here you will get the u naught is equals to u by 2. So as you got the velocity at this position, it is u by 2. Now you can just use this formula to get the amplitude. Right, so if you see here, we want the amplitude, and the frequency will remain, as we know, it only depends on the mass and the proportionality constant, that is spring constant. It is under root k by m, right? Inverse of that time period, inverse of that, if you see, it is inverse of time period in this, right? So it will be under root k by m. So just put it here. So I will write down v square is equals to, so v square you can put the value, it is u square by 4. X you can see it is this. So I will write down a square is equals to, so if you see this will get cancelled out by 2, right? So I will write down it is 4 and it is 2. So I will write down it is mu square by 2k plus this will get added And now if you take under root and remove this square, this is the amplitude. Now you can check for the option mu square by 2k plus this. So this is u. So if you see, C is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.